Okay, here's a problem about friction. Let's try this one. We'll try number 21. 60 kg student sitting on a hardwood floor does not slide until pulled by a 640 Newton horizontal force. Determine the coefficient of static friction between the student and the floor. As usual, we want to have a little drawing. Here's a student sitting on the floor, and somebody's pulling, and maybe the student's sitting on some little platform or something, and there's a rope. And we're pulling with some kind of a force, and the student finally slides. Now, the force diagrams here that matter are there's a force on the student down, which is the student's weight, and then that must be balanced by a normal force up, okay? Because the student's not accelerating in the vertical direction. So this one is also mg, just pointed in the other direction. Now there's a force here that I'm pulling with, and there's a force of friction in the other direction. So I might call this the applied force, and I'll call this the force of friction. And what happens here is if I start pulling, and maybe I pull with a very little force and the student doesn't move, then the frictional force must be the same as the force that I pull with, because it balances out. The student's not moving, the student's not accelerating. So I pull a little harder, the student still doesn't accelerate, I pull a little harder, he still doesn't accelerate. That means the frictional force keeps getting bigger and balancing the applied force no matter how hard I pull. But at some point, finally, I pull with a force that is big enough that the frictional force cannot get that high. And so at that moment, the applied force gets bigger than the maximum frictional force, and at that point, the student starts to slide. So the force of friction, in this case the force of what we call static friction, the maximum that it can be, is equal to what we call the coefficient of static friction times the normal force. Okay? So in this particular case, we're saying that at 240 newtons, when we reach 240 newtons, that's the point. That's as big as we can get before the student starts to slide. So at 240 newtons worth of pull, that's a little ugly there. At 240 newtons worth, we finally reach the point where the student starts to slide. So the neat thing is we can figure out the force of static friction, the coefficient of static friction very easily this way, because the student has a mass of 60 kilos. So that means the student's normal weight is about 600 newtons. And I can actually calculate now that the static coefficient of static friction is going to be 240 newtons divided by 600 newtons. It's as simple as that, and we get whatever that is. So 24 over 60, if I add 4 into there, I'll get 6 over, let's see, 4 over 10, 2 over 5. It looks like we got about 0.4. Okay? And that's as simple as that. It means that if I take this coefficient of 0.4 and I multiply by the normal force, and the normal force could be of anything on this surface now, then I can get the maximum frictional force before an object will start to slide.